class. Welcome to 3D Printing and Makerspaces, presented by Group 1. 3D printing is the process of creating an object using a machine that puts down material layer by layer in 3 dimensions until the desired object is formed. Each of these printed layers is a thinly sliced, horizontal cross-section of the eventual object. The whole family of 3D printers and the equipment can be called additive manufacturing, or AM for short.
Let's watch a quick video.
"3D printing technology is already changing the way we produce objects, from tools and toys to clothing and even body parts. 3D printing is part of a process known as additive manufacturing, where an object is created by adding material layer by layer. Additive manufacturing allows designers to create complex parts for machines, airplanes, and cars at a fraction of the cost and time of standard means like forging, molding, and sculpting. Now, smaller, consumer-friendly 3D printers are bringing additive manufacturing to homes and businesses. The first step in 3D printing is to create a blueprint of the object you want to print. You can use modeling software like Blender to create your own designs, or you can visit websites like Thingiverse or Shapeways to find objects other users have 3D modeled. Once you have a finished design, it's time to send it to the printer. Some printers, like the MakerBot Replicator 2, have renewable bioplastic spooled in the back of the device, almost like a string. When the printer receives the data, it pulls the material through a tube, melts it, and deposits it to the plate where it instantly cools. As you can see, the 3D object is created through layering, where the printer will add one layer of the object at a time until you have a fully formed structure. The most common material used in 3D printing is plastic, but the use of some other materials allow for the creation of some pretty amazing products beyond simple tools and toys. 3D printing food is becoming very popular, and additive manufacturing has allowed for the creation of some pretty intricate treats. In the medical world, doctors are testing biomaterials for regenerative medicine. By using a patient's cells, doctors could 3D print small body parts like ears and noses. Some surgeons have even tested 3D printed organs for transplants. Recently, giant 3D printers in China printed 10 houses in just one day and at a cost of less than $5,000 per house, proving just how cost and time-efficient 3D printing can be. For more on 3D printing, check out Mashable's latest coverage. And don't forget to watch the other videos in our Mashable Explained series.
Why is 3D printing so popular? Well, it gets touted as the innovation destined to transform nearly everything, from manufacturing to medicine to entrepreneurship. There is potential for any person or any small business to manufacture products on demand without inventory or overhead. It has the ability to change medicine by offering individualized 3D printed organs based on a patient's tissue type. As 3D printers become more and more affordable, the opportunity to create, sell, and distribute products will become endless. The positive aspects of 3D printing are that it allows for customizable user design. The sky is currently the limit. It also allows for rapid prototype design and manufacturing, while reducing manufacturing costs. It also reduces the need for massive warehouses and inventory stockpiles. And we've already seen some viable advances in the healthcare industry. The negative aspects of 3D printing are that there are limited uses for the printed materials, as they are usually made of plastic or occasionally some form of edible. 3D printing also allows for the creation of dangerous items. I can remember the first time I heard about 3D printing a couple years ago was when a savvy young entrepreneur was printing and selling plastic guns. There are also many copyright issues that are yet to be resolved. The cost of 3D printers is prohibitive and hasn't yet reached the point to where they are accessible to the masses. 3D printing can also lead to a decrease in jobs, as the printer may replace the assembly worker. Now that you are eager to have your own 3D printer in your classroom, where would you put it? Why, in a makerspace, of course. A makerspace is a physical location where people gather to share resources and knowledge, work on projects, network, and build. This idea of a collaborative studio space for creative endeavors has caught hold in education, where the informal combination of lab, shop, and conference room form a compelling argument for learning through hands-on exploration. Why are makerspaces so popular? Makerspaces are changing the landscape of the classroom from passive learning to learning through exploration and discovery. Students connect concepts and build upon them to create new ideas and discoveries. Students can use resources such as 3D printers to explore and create whatever they want to contribute to their production in the makerspace. Some of the positive aspects of makerspaces are that building and tinkering empowers the students in their learning process. They place students at the center of the learning experience. Such experiences connect students to the real world. Makerspaces encourage creativity and allow students to let their personalities shine. They also help develop skills that encourage activity in their communities. The negative aspects are that educators may not be prepared for this type of learning. They may also feel that they don't have the time or resources to construct an effective space. Makerspaces are designed to be less structured than typical classrooms, which comes with an additional set of pitfalls. And educators will need to be well skilled at ensuring an effective balance between learning and fun. What might topple 3D printing and makerspaces off the radar? Well, even though 3D printing has the ability to change the marketplace and the classroom, many can't afford it. The cost currently outweighs the benefit. In addition, there is no legal control over 3D printing or copyright laws in place. As 3D printing becomes more popular, the control over copyright and what someone can print might limit the potential outputs. In terms of makerspaces, there is some criticism that a makerspace isn't effective as it has cutting-edge technology and equipment, such as a 3D printer or power tools. This might cause teachers to shy away from the concept because they feel that they don't have the resources to create a true makerspace. However, a makerspace can be any place where students can explore, invent, create, and discover. And teachers or schools do not have to have the high-tech resources or tools to create a true makerspace. We will wrap up the presentation leaving you with a couple videos that depict 3D printing and makerspaces in action in the classroom.
Kid Design is a social enterprise that introduces children to design by teaching them to use technology as a creative tool. Back in 2010, I read that children spend an average 7 hours a day in front of screens, mostly passively, and it disconnects them from the real world. At the same time, 3D printers, which literally connect the digital and physical worlds, were becoming more popular, affordable, and simple, so schools started buying them. Unfortunately, a lot of these machines ended up collecting dust in school cupboards because the teachers didn't know what to do with them. And we saw an opportunity there and focused on designing creative projects for 3D printing in education. Our latest product, Kidville, is a collaborative city design project where each student gets a design brief for a building, and they're guided through a term-long process of research, ideation, sketching, urban planning, 3D design, and printing. This curriculum includes teamwork, project management, and practical skills that equip children for jobs of the future. Teachers love Kideville as it makes this complex subject simple and fun, and the kids end up saying they want to become designers, architects, and engineers. So now we need to take it to the next level and develop an interactive digital platform for our projects and scale our social and educational impact to more children worldwide. Our team has great experience in design, education, technology, and business, so we just need your support to make it all happen.
Welcome to Makerspace. Hey guys, this is not to be a little messy. Hey, look at through the magnet structure. And then we found out that if you twist this part, that's the volume. We found the motor attached to the cart under this circuit board. It's working! Can I pick it up? Now put it back. That car that we made was just the best thing we ever made. Car.
Does their ship go in the ocean or fly in the air?
It like flies in the air. They have a tank right here. A new modern like spaceship. With a Mr. Kitty driving it. B-50. I found so much head. He came up with the idea.
For those of you who would like to get started with your own 3D printers or makerspaces in the classroom, here are a few tips for your reference later. And finally, here are some resources that were used during the course of this presentation. On behalf of Group 1, thanks and take care.